I also have a short talk here to share my experience writing career proposal and other proposals and serving on the panels. So first a disclaimer page. The information that I'm going to present today is based on a number of things. First of all, I have strong beliefs how science moves forward, so it's strongly personal opinion. I have served, I have had 2 experiences writing career proposals. One was rejected, obviously, and the other one was an accept. I have read and reread the feedback that I got in both cases for the accept one also, because I really value the feedback. I helped some other young faculty get their career proposals. And I have served on several career panels. As you can imagine, I'm a little older than the other speakers here. I got my career proposal awarded about 6 years ago. And lastly, they don't necessarily represent the views of NSF or any of its employees. Okay. So I have seen in my experience that successful proposals are based on this formula. They have to be visionary and high impact, and you've heard about this a lot today. They have to have a potential to jumpstart a successful career for the faculty member in the proposed area of research. They have to have a concrete career plan, not just a research plan, but a concrete career plan. What would you do based on this, the results of this proposal or project at the end of the 5 years? And they have to focus on integrating research and education. And like I said, this is going to be mostly repetitious because a lot of the people who have experience have talked about these issues over and over, but perhaps one more repetition can't hurt. Okay. So for career proposals, there are certain other requirements or certain emphasis on components that have been mentioned. They are long-term because, like I said, they're intended to jumpstart your career. They have to have, obviously, a research plan. That includes a problem statement, some discussion of prior work, and then the novel approach that you propose to solve that problem. They have to have an experimental plan, some preliminary analysis of feasibility and potential impact. And then you have to have a career development plan, a clear path that indicates how you're going to take this project, the results of this project, and launch your career. And they have to have a very well integrated education plan. Okay? More so for career proposals compared to the regular ones. With the regular proposals, with the boilerplate statements on education, you can get away with it. But for career, you have to have a more concrete plan. So a little bit more on those components. The problem statement, visionary and high impact problem. I know this is very vague, and it was very vague when I started, but it is what everyone emphasizes. So you have to think long term, why this problem is important and why this is going to have a high impact, your solution. Okay? Do not strive for incremental improvements on one problem or even several problems. You could say, okay, this is my general area and these are the several problems that I'm working on and this is what I'm going to do. That's even not good enough unless they in collection solve a larger problem at hand or move the area forward. If you are thinking about extensions of your PhD work or postdoc work, they're generally not accepted. They don't really get the attention. But on the flip side of it, it is required that you're going to have some expertise and experience in the area of research. So it's a double-edged sword. For instance, what you can do is you can take the expertise that you have obtained during your previous career as a PhD student, as a postdoc, or even working at a company, and then you can propose to apply it to a new domain. Of course, when you do that, you have to demonstrate that you have really studied this new domain, you understand it well, and coming from a different domain, you have a new angle to look at these problems. And now you're well positioned to make a leap in that new domain. Okay? So the other approach you can take is a stay within the domain, but introduce an idea or a vision that's going to provide a paradigm shift. It's going to revolutionize how people are looking at this problem. So both are hard, but they are doable, as most of us demonstrated here today. So a little bit about my experience. My PhD was in mixed signal RF circuit testing, and I basically use very high-level models, the abstraction at the higher levels of the system. But in my PhD studies, I noticed a glaring lack of statistical analysis techniques to fuse the process variations with defect mechanisms. So I realized, okay, this is a really important problem, because if I solve this problem, it's going to have applications to a broad area. And in an effort to be broad, I wrote my proposal on the more generic problem of how do we analyze process variations. And since this is very generic, obviously, I had to come up with something that applies to everything. Okay, so I submitted to CCF, and I got rejected. Now, reviews indicated, when I looked at the reviews, they indicated that, okay, your experience is in testing, fault modeling, structural testing. What you're proposing to apply statistical analysis to everything has been what statisticians have been working for decades or centuries. So you can't really make a big contribution to everything. Okay? Focus on the domain, but solve a problem that is a big whole. Okay? So then I noticed that a successful proposal does not necessarily solve every problem that is out there that you're intending to focus on. So you have to think that 10 years from now, how is this problem domain going to be impacted by your solution? Will you have people changing their attitudes or changing their minds in terms of approaching similar problems in the field based on your results? Okay? Will the solutions apply to the problems in the future? So you have to demonstrate that, okay, this is a problem right now, but it's going to be an even bigger problem tomorrow or in the future, or it's going to move along the area in that direction. So in my second try, I did refocus the ideas around the fault-based testing, which has failed to produce any successful integration in the industry. So I argued that this stalemate was due to either impractical approaches or incomplete approaches from a computational perspective and accuracy perspective. So I proposed an approach that filled in this gap, and about the long-term impact that I argued for increasing need for structural and statistical methods, because as we move to even smaller and different technologies, this becomes an even bigger glaring problem. So I argued that if I solve this problem, it's going to even have a bigger impact in the future. It's not solving a problem that is there right now and people will forget about tomorrow. Okay? So that was the approach that I took. Okay? So a career proposal has to also have a strong review of the prior work in the area to demonstrate that you're knowledgeable, even if it's your own area of expertise, but more so if you're applying your expertise in a new domain. Okay? So you need to do a thorough literature search. I've seen, in my experience, 60 to 100 and even more references are typical. References are not part of your page limit, so you can be generous there. Okay? So it would be better to group references in common themes so they're not scattered all around, so you can tell a story in your prior work too. So this is a group of approaches that did this. This is a group of approaches that solved the problem from a different angle, and so on. That also helps you explain that you have a new problem that has not been addressed before, or you resolve a major barrier to progress in the field, or you're applying your expertise from a different domain, hence you're going to make a big leap in this new area. So that helps you structure your thought process around the prior work as well. Don't skip any relevant publications. Also, don't skip any publications of people who might be on the panel. Of course, you cannot guess, but you know who who are the players in the area. So be tactical also in your references. Okay. So in my approach in the first try, when I kept the area too broad, of course it came with potential risk on prior work as well. I had over 100 references, but still there were critical keywords that I failed to cover in my prior work, and that came through in the reviews. Okay? When I refocused, I felt more comfortable because that was my area of research. I knew I covered it all. And then I was able to demonstrate more concretely that what I'm proposing is indeed novel, and it will introduce the paradigm shift that I was talking about. Okay? So if you're applying your expertise to a new domain, of course, this is a little harder, but it's still doable. You're going to have to read a lot more papers, though. So novelty. Based on my observations as a panelist, every proposal has to have something novel in it. Right? So that goes without say. But career proposals have a particular emphasis on novelty. So what does that mean? There are two components that you need to address. First, the problem that you propose to address is a challenging problem. This has been addressed before. If it's a trivial problem, or if it even sounds trivial, then you have to work on it more. Okay? And you have to convince your reviewers that are in your immediate area of expertise or immediate area that you're proposing, also reviewers who are not immediately in that area, because the panel is going to be made up of people from different backgrounds. And the second thing, the second component of novelty is that what you're proposing is new and a superior approach. So you have to address all these three things. Okay? You need to clearly define novelty, and you need to note that, like I said, the panelists are coming from broad backgrounds. So if you are addressing people not immediately in your area of research, it's harder to convince them of the challenging aspect. Okay? So you have to work on that aspect. For people who are immediately in your area, it's harder to convince them of the superiority aspect, because they have done this and they don't like to be challenged on that. My approach is better than these prior works. Okay. So what was my approach to that? In my first try, I explained the novelty and the vision of my proposal implicitly. Okay, so these are smart people, they're going to figure it out. Well, it doesn't work that way, because people have limited time to spend on these proposals. Usually you are given 6 to 8 proposals to review, and yes, you're given 3 weeks, but you're not going to spend all these 3 weeks on just reviewing proposals. So an hour or two is on the average. I spend, honestly, 2 to 3 hours per proposal, and I can't spend any more than that. So you have to understand that not every word is read with great attention. So in my second try, I noticed this, and I had more explicit explanation. What I propose to do, why this is different from prior art, why this is superior, and why this is visionary. Now, originally, I wasn't a person that is too fond of bullets. Okay? I figured that everything had to be smooth. Everything had to flow in sentences and paragraphs. Now, over the years, as I write proposals and papers and get rejected, I became more and more a fan of bullets. Okay? Use bullets. Don't shy away from them, because when you itemize your contributions, your novelty, and so on and so forth, it's easier to understand, especially if people are just skimming through your proposal, which will happen, unfortunately. Okay? So experimental plan. This is also one of the crucial aspects of the proposal. You need to show that you have a clear plan to define success. Okay? 5, 10 years from now, how do we know that you have been successful in your career project? You also need to show that you have the means, you have the computational means. If you need experimental data or large amounts of data, you have access to them. You have access to the necessary equipment. All these have to be shown in your proposal so people believe that you can accomplish the work that you're proposing. Okay? So the touchy subject of preliminary analysis. How much preliminary analysis should you include in your proposal? Now, there are 2 components of the preliminary analysis. One is the potential benefit, and the other one is either feasibility or superiority, whichever way you want to phrase it. Generally, I recommend that you have 6 to 12 months at least of experience in this area or in this problem domain that you're addressing. 1, 2 publications in the area couldn't hurt, and you can, of course, take the results of the publication and include it in your proposal. Okay? So what should they have? What should these experiments have? They could have a demonstration of ideas on small scale. So if you're proposing to do, if you're proposing to solve a problem, let's say on large circuits, right? You can take a toy circuit and demonstrate some of your ideas on that toy circuit, and then explain to the reviewer why this is working or why this is superior and so on. Okay? Or you can take a smaller part of the overall problem and demonstrate on a large scale problem. So you can take these samples or nuggets of your results and demonstrate that this can be done, it's feasible, and it's going to have a potential impact. Okay? And use visual representation of your results. Okay? If you are a graph person, use lots of graphs to show to make your point. So you need to make your point in a visual way so people, when they look at your proposal, they can understand what you're claiming. Merely using sentences or even convoluted ways of showing data is not a good idea. And also, do make your figures large enough for people to read the axes and so on. Right? Okay? So my experimental plan had 2 parts. We, in one part was showing that the proposed approaches had better performance for academic scale circuits. So this is the toy circuit that I was talking about. And then showing that this can be applied to industry scale circuits. Okay? So for the first part, I had some preliminary results that I demonstrated from a computational perspective, from a accuracy perspective, and so on and so forth. And for the second part, since I don't have access to industry grade circuits myself, I obtained support letters from industry collaborators, explicitly stating that they will help me gain this access. Okay? This was very helpful. A generic support letter from industry is not very helpful, but if they can state how they're going to help you achieve your goals and why this is important for them, and also why your company is not willing to fund it at this point in time, that will be the best letter that you can get from your collaborators. Okay? So the career development plan, it is also a crucial component. You're going to have to lay out that at the conclusion of this project, how are you going to take these results and how are you going to run with these results? How is your career going to be based on this project? Okay? And how can you take the results and apply it to a broader domain or move forward in the field? What can you do building up on this project? It's not just a 5-year project, but it's something that you build on, and you need to demonstrate that. Education plan. Like everyone else said, this is very important. One of the reasons why my first proposal got rejected, probably not the only reason, but one glaring reason was that it was weak on the education plan. So I had the boilerplate items. I'll develop a course. I'll do undergraduates. I'll recruit undergraduate students, and so on and so forth. Okay? But in the second try, I was more explicit and that's and concrete, and that's what the reviewers are looking for. They have written proposals too, so they know how it goes. If you don't think about it, you put the boilerplate items to just as a check mark. Okay? They want to see that you have actually thought about it and you have a concrete plan. Okay? Even if you're going to go with the boilerplate items, you have to have a concrete plan. How can you use the results of this project to enhance the class material? Okay? Or are you going to develop new classes? What are they going to focus on? How are they going to integrate with the rest of the curriculum in your department? Can you use the results of this project to update existing curriculum? If so, then you're going to have to get an okay from your department chair, and they should probably state it in their support letter. Okay? My approach to the education plan, this is the second time around. The first time around, I have to admit that I didn't really think about it much. And I had never come to a workshop like this, and I had really not sought any input from my peers. So that was one of the mistakes that I made. First of all, I'm a true believer in education, and this is no lip service. I spent a tremendous amount of time preparing for my lectures and so on and so forth. The education plan should have a good mix of graduate and undergraduate classes to teach. It's not about the number of classes, but at least you show that you can cover various levels. Okay? For instance, I've been teaching a sophomore or junior level circuits classes and developed a new course on testing myself, and I've been also teaching another course in the graduate domain. So what did I propose to come to the conclusion? First of all, integrating new research into the undergraduate curriculum is tough, but I propose to do this nonetheless. But I kept it simple, because you're not going to have undergraduates understand cutting-edge research. You're going to have to give them nuggets of that cutting-edge research. The results or the problem statement itself may be good enough, but you have to have a plan. So I argued that in most of the curriculum that I know of, students never learn about the downsides of manufacturing, defects, process variations, mismatch, and so on and so forth. Never mentioned in the undergraduate curriculum. Okay? So I proposed to introduce some of these concepts in the sophomore and junior level classes. And I did get an okay from my department chair. I was at Duke University at the time, and that was explicitly stated in her letter. Okay? And so I had a plan to include examples of how process variations impacted designs, how you can optimize a design, and then that optimized design may end up performing poorly or even more poorly than a non-optimized design due to process variations. I had a few concrete examples, and I developed homeworks and projects around those examples. Okay? I also proposed to develop a new course in analog and RF testing, but first I argued the need for it, that these kinds of courses are lacking in the nation, and there's a need for it, and I got support letters from industry for that, indicating that they have a hard time finding new graduates with any knowledge of testing when they recruit. And then I had a syllabus that's laid out for that purpose. So I demonstrated that I actually thought about this. I had a plan to teach this course, and it was endorsed by industry as well as my department chair. I also defined a concrete but small project for undergraduate students. I got engaged with the program that was at Duke at the time. It was called the Pratt Fellows Program, which recruit undergraduate students for research. So there's an infrastructure. I made use of the existing infrastructure, and I recruited students based on that. Okay. So this was my plan. As you can see, it's boilerplate, integrating results of research into undergraduate curriculum, developing a new course and undergraduate research. But I had very concrete steps to achieve those goals. Okay. So broader impacts, there are standard lines, as you may know. Integrate with education. This is a must anyway, but it also goes into broader impact. I'll recruit minority students. I'll involve undergraduate students. These are all standard statements, and you may get away with them if you provide a little bit of detail in a regular proposal. For a career proposal, you have to be a lot more concrete. But they're okay to check the box, but they're not exciting. What will be exciting, if you're going to talk about undergraduate research, you need to explain more concretely what kind of projects will you have for them. Is it doable within 1 or 2 semesters? Undergraduates don't hang around that long. You're going to have to train them. You're going to have them contribute to something, and it needs to be completed within 1 or 2 semesters. So it has to be concrete, small, but relevant part of your project. Okay? Minority involvement. Okay, everybody can say that they're going to recruit women and other underrepresented groups, which is okay. We all strive for that, but it's not easy. So you must have a concrete plan to do so. Why would minority students be attracted to your program any more than they'll be attracted to somebody else's program? Is there anything specific that you will do for that purpose? Okay, the last item is always, how are you going to save the world with this project? If you have a good explanation for that, it's always worthwhile including that. Okay. So support letters, the chair letter is definitely required. Do not skip it. Your proposal will not be reviewed. The standard items include that you're eligible for the career award. Obviously, the department or your school is the only one who knows that you're untenured, so it has to go there. And there's a statement indicating that this institution fully supports you and your career. More importantly, if you're going to propose any changes to the curriculum, graduate or undergraduate, seek to have that included in that support letter. That makes it a lot more precise, and also that shows you that you do have a concrete plan. And something that goes beyond the standard support would be nice. If you require a certain piece of equipment, the department chair can secure its use or indicate that you have access to this equipment. The department chair can also pledge some additional funding. For instance, in my case, my chair pledged some additional funding for me to travel to, for instance, NSF, to visit program directors or other institutions to promote my ideas, and so on and so forth. Okay? Or they can pledge some relief from teaching. Even though it has to be a part of the plan, they may reduce your teaching load to 1 a year or 2 a year if it's more than that. Okay. So my final words of wisdom, writing a proposal takes a lot of effort. You have to plan ahead. And just like writing a good paper, reviewing others' proposals definitely helps. So don't be shy of asking. You can ask around different people for their proposals, and most people will send them to you. Okay? If you don't get a response, ask again. A lot of people are busy. They don't necessarily respond all the emails in the inbox at once. Okay? Also, ask to serve on the panels. This is probably said quite a few times, but I cannot stress the importance of this enough. Get a mentor and have someone or more than one person read your proposal and give you a black eye. That is very important. And if you do get rejected the first time or the second time, don't take it personal. Okay? Maybe a number of factors. Take a month break and read those reviews, however grudgingly you might. But they are very, very helpful. But if you just address that specific comment of that specific reviewer, don't expect to get it the next time around, because that reviewer may not be there, or they may still not be convinced. So you have to take the reviews, fuse them, understand them, and reorient your proposal around that. Okay? And then support every claim you have in the proposal with preliminary data. If you have intuitive explanation for something, include that. You can have support letters from peers if that is necessary, industry, so on and so forth. So don't just leave ideas or claims hanging around, because that leaves a bad taste in people's mouths. And that is my talk. Thank you.